Now, what do we have here? Squeeze theorem. Now, evaluate the following. The limit of x sine 1 over x at which x tends to 0. Limit x sine 1 over x, x tends to 0. Now, this sine 1 over x, sine 1 over x is numerically less than 1. No matter the value of x, sine 1 over x is numerically less than 1. So that means it falls in this interval minus 1 less than or equal to x less than or equal to 1. So to evaluate limit x sine 1 over x at which x tends to 0, that means minus 1 is less than or equal to sine 1 over x less than or equal to 1. And here the function is x sine 1 over x. So we can multiply all two by x. That means minus x is less than or equal to x sine 1 over x less than or equal to what? X. And that means the limit of this minus x at which x tends to 0 should be less than or equal to the limit of x sine 1 over x at which x tends to 0 should be less than or equal to the limit of x at which x tends to 0. Now, the limit of minus x at which x tends to 0 is what? Is 0. And the limit of x at which x tends to 0 is what? Is 0. That means the limit of this is less than or equal to the limit of this, less than or equal to what? The limit of this. And the limit of this is 0, and this is what? Is 0. That implies that the limit of this function is 0. So the limit of this is 0. And number 2, limit x tends to 0, x raised to power 4 sine 3 over x. Now remember that sine 1 over x is numerically less than 1. So that means it falls within this interval. Minus 1 less than or equal to x less than or equal to 1. So the limit of x raised to power 4 sine 3 over x, that means minus 1, is less than or equal to sine 3 over x less than or equal to 1. Similarly, minus x raised to power 4 is less than or equal to x raised to power 4 sine 3 over x less than or equal to x raised to power 4 if we multiply all through by what? X raised to power 4. That means the limit of minus x raised to power 4 at which x tends to 0 should be less than or equal to the limit of x raised to power 4 sine 3 over x at which x tends to 0 should be less than or equal to limit of x raised to power 4 at which x tends to 0. Now the limit of this function x raised to power 4 minus x raised to power 4 at which x tends to 0 is what? 0. Should be less than or equal to the limit of this function and less than or equal to the limit of this function, and the limit of this function is what? Is 0. So that means this is less than or equal to 0, and the limit of this, which is 0, is less than or equal to what? This. So that means the limit of this function x raised to power 4 sine 3 over x at which x tends to 0 is 0. Now the last one, limit n tends to infinity of sine n squared plus n over n plus 2. Now applying squeeze theorem here also, minus 1 is less than or equal to sine n squared plus n less than or equal to 1 for any value of n, for any value of n. So that means minus 1 over n plus 2 is less than or equal to sine n squared plus 2 over n plus 2 and less than or equal to 1 over n plus 2. That means the limit of minus 1 over n plus 2 at which n tends to infinity is less than or equal to the limit of sine n squared plus 2 at which n tends to infinity should be less than or equal to the limit of 1 over n plus 2 at which n tends to infinity. Now what is the limit of this? The limit of minus 1 over n plus 2 at which n tends to infinity, when we divide all 2 by n, that will be minus 1 over n over 1 plus 2 over n. That's minus 1 over infinity, that's 0, over 1 plus 2 over infinity is what? Is 0. The answer is 0. Now similarly, the limit of 1 over n plus 2 at which n tends to infinity is also what? Is 0. So the limit of this, which is 0, is less than or equal to the limit of this, less than or equal to the limit of this, which is 0. That implies that the limit of this function is 0, and the limit of this, limit x sine 1 over x at which x tends to 0 is 0. Limit of x raised to the power 4 sine 3 over x at which x tends to 0 is 0. And the limit of sine n squared of plus n over n plus 2 at which n tends to infinity is 0.